Numerical methods, problem 13.22. Use the golden section search to determine the length of the shortest ladder that reaches from the ground over the fence to touch the building's wall. From figure P13.22. Test it for the case where h equals d and d equals 4 meters. So, we notice that the box is square, 4 by 4, and it matches our outer triangle of the ladder, and everything should be on a 45-degree angle. So we can tell by the box that, or the fence and the box given in the figure of h by d, that the wall should be 8 meters high and the ladder should be 8 meters away from the wall. So we simply need to use a squared plus b squared equals c squared, or a squared plus b squared, and subtract c squared from the right side of the equation, and then set up our anonymous function here where we have our a squared 64 plus our b squared 64 minus our c squared, which we were looking for. So problem asks us to use golden section search, so that's what we will do. We have our lower bound of -14 and our upper bound of 15, making sure they are not the same, because if we have -15 and 15, then the search won't work. And so here's our golden ratio that we computed, and we simply multiply the golden ratio by our upper minus our lower, and then we find a value for a 0.1 and a point T2 by taking our lower and adding the value d, taking our upper and subtracting the value d. And then we go through the rest of our golden section search, doing our comparisons of the values that we arrived at, such as if T2 is greater than T1, then our upper bound will now be T1, and so on. And so we go through that loop many times, have it 100 times iterations, and then we can plot it up. So here is our graph, or our parabolic graph, and here are our estimates to our maximum. Our lower bound is in red, our upper bound is in green. And so, since we set the equation to 0, our maximum is at 0, and so our lowers and our upper estimates are approximately at 0, and the maximum is at 128. So now all we have to do is take the square root of 128, and we notice our ladder is 11.3137 meters long. And that is it for problem 13.22.